Hello everyone, my name is Tommi Salmi and I will be presenting my machine learning project here. My problem was that I wanted to classify hand-drawn objects to 12 categories. Here we have a few examples on some drawings that the model should be able to classify. But yeah, let's start with the data that I used, since all the machine learning problems need data. So here you can see example on the data. So the labels of the data point, one data point basically is a drawing, and the label is the category that the drawing represents, and the features are the bitmap. Features is the bitmap that you can see here. So basically 28 to 28 matrix with values from 0 to 55. The higher the value, then that means that a person has been drawing. So this is a simplified dataset from the drawings, but it will do for our purposes. And this all is gathered from Google's Quick Draw dataset. And for the two labels that I'm looking at, wanting to classify, there was 1.2 million data points. So that is definitely enough for our needs. Next up is model. All the machine learning problems, it has data model and loss. So I had two models that I tried. Basically both are artificial neural networks, because from the course material and from online I understood that it's the best way to for image classification tasks. So here you can see example of my first model. It has an input layer of 784 neurons is the number of elements in the bitmap, and then it has hidden layer of 128 neurons, and finally an output layer of 12 neurons. And I'm using activation functions ReLU for the two first layers, and for the output layer I'm using softmax. I won't go into too much detail about them, but basically I did the research, and ReLU is an efficient activation function that works with many neural networks, so it could be used here as well. It made the training part a bit faster, and softmax is often used in the output layer, especially for classification tasks. And the model 2 was very similar. It was the same with one more hidden layer here in the middle, so basically a bit more complex one with more parameters to tune. But yeah, the next thing we need to do is train the model, and for that we need a loss function, obviously. And the loss function I used here was the multiclass entropy loss. You can look that up, how it works. Basically, it's used for multi-classifier networks, so that's why I chose it. And when I started training the data, I wanted to split the data set. So I wanted to use 80% of it to training, and then 10% to validation, and finally 10% to test as a test set that I will finally use with the chosen model. And I trained the models in 20 epochs. So one epoch is basically an iteration with the same training and validation sets. And the results that I got were pretty good. So for both models, the training errors were approximately the same, but for the model 2, it had higher training error and no higher validation error and lower validation accuracy. So I didn't want to choose that. Actually, you could see that model 2 towards the end of the iterations, it really decreased the accuracies and increased the validation error. So yeah, and here CNN might be more accurate, but for my purposes, I didn't want to use it because I wanted to try a plain network. Thank you.